Today we're going to cover section 6.4, graphs of polar equations. And our primary focus is going to be on graphing equations that don't have common Cartesian equivalents. So last time, right, we talked about, circles, lines, stuff we were already familiar with. It was just those things could also be written in polar coordinates. Well, if we are going to graph some of these trig functions in polar, because that's really what we're going to be focusing on here. You'll see that A, B, and C, that these all look like things you've graphed before, other than you're used to it saying y equals something with x, and now it's r equals something with theta. And so is what our first step is going to be is to sketch the sine or cosine function in Cartesian coordinates. So being able to graph y equals 1 minus sine of x will be helpful here. Okay. And after you do that, you'll make a table of values. And what we'll do is we'll take those table of values to help us create our polar graph. So let's try out this first one. Let's just make a quick sketch here of y equals 1 minus sine of x. I'll leave it as r and theta, but again, you can imagine this just like we were doing this earlier in the quarter. Okay. And that's probably a lot further than I needed to go. Let's go ahead and mark this as the r axis and the theta axis. And let's go ahead and put in our scaling here as well. So this should look like the graph of y equals minus sine of x, but shifted up 1 unit. So what we really want to do is we'd like to go up. Instead of up to 1, we want to go up to 2. Right? This is where the center of our trig function is going to be now. The center of the wave is going to be at 1. And let's also sketch in our x-axis. And right, the spacing for this should be pi over 2, the period over 4. So pi over 2, pi, 3 pi over 2, and then finally 2 pi. And remember, sine of x, typically it starts at the center of the wave, which would be right here, and then moves up. But since we have this negative in front, right, that's going to reflect this vertically. Okay. So rather than going to the top of the wave next, we should actually go to the bottom of the wave. It should be 1 unit down, right? The amplitude is 1. And then back up to the middle, and then to the top, and then to the middle. All right, and the whole point in graphing this is that we can now make a table of values for theta and r. Okay. See if we can straighten that out a little bit. There we go. And one more line here. And what we want to fill in here is theta and r. So theta and r. So what we're going to be thinking about is these little intervals. So 0 to pi over 2. I want to know what's happening to r over that interval. So 0 to pi over 2. What is happening to r over that interval? And it is going from, right, 1 to 0. And so what we would do is we would come over here and we'd start off with this 0, 1 that is in polar coordinates, 0, 1. So if theta is 0, we're on the positive x-axis, and if r equals 1, we should be on the circle of radius 1 here. So you can see that little dot there. And I might even try to make that dot a little bit smaller. Let's do that. Just because we're going to be trying to sketch this really neatly here in a minute. And then after that, in the end of this interval, when theta is pi over 2, r is 0. So as we start rotating around here, we should end up actually back at the origin. If r is 0, it means we're 0 units from the origin. And let's just go ahead and connect these with the smooth curve. But note that as we do connect these, the radius should never exceed 1 or be less than 0. And I shouldn't call it the radius r here. Let's go ahead and sketch this in then. And this is actually a little bit more curvy than it'll look when we go to graph it on the calculator, but that's fine. Okay. And let's think about the next interval. So the next interval that you see is pi over 2 to pi. And maybe I'll do it in a different color so we can keep track of all this. So pi over 2 to pi. And as we do that rotation, if we look at the graph, we can see that, well, at pi over 2 it was 0, and then at pi it was 1. So when we're at pi, so when we've rotated pi radians, r is supposed to be 1, so we should be back out here again. And again, the idea is as we go from a r of 0 at pi over 2 radians, we want to go to r equals 1 at pi radians. And so this is going to make a very similar look here. And notice again, I've never exceeded r equals 1. I'm just connecting those two points with a smooth curve. Okay. And on to another section. Let's try this time pi to 3 pi over 2. And if we were to look back up at our graph, from pi to 3 pi over 2, r is going from 1 to 2. So 1 to 2. So let's think about this 3 pi over 2 for theta and r equals 2. So 3 pi over 2, this is the negative y-axis, right? And when we're on the negative y-axis, r needs to equal 2. So I'll go out to the circle of radius 2. And again, we want to connect these with the smooth curve. And we should never be less than r equals 1 or more than r equals 2. And I'm getting this from looking at this here. So 1 to 2. Okay, so maybe it looks something like that. And one more to go here. So let's go 3 pi over 2. There we go. 3 pi over 2 to 2 pi. And as we rotate or move from 3 pi over 2 to 2 pi, r is going from 2 to 1. So at 2 pi, once we've made one full revolution, we should come back to r being 1. Okay. So that means as I go from here and rotate towards 2 pi, r should get closer and closer to 1. So it should probably look something like this. And we kind of have a heart shape here. Again, it will be a little less curvy up top there when we go to graph this on our calculator, but what I'd like us to do is check this out on our calculator now. Now that we're in our calculators here, let's go ahead and change our mode to polar mode. So go down to function and then over to polar and hit enter. And also make sure that you are in radians. When we were looking at our angles, we were looking at angles measured in radians. Next, let's go into our y equals, which is now really going to be an r equals menu. And let's wipe out this equation that we typed in here yesterday. And now we have 1 minus sine of theta, right? And remember, when you hit the X button when you're in polar mode, it's going to give you that theta. And then next step, let's go into the window. And right now it is 0 to pi. Well, we went 0 to 2 pi when we graphed this, so let's try 2 pi. And let's leave theta step at 0.05. And x min and x max, we have minus 5 to 5 here. I suppose that actually is pretty close to what we have on our polar graph as far as the scaling goes. So why don't we just leave it like this and we'll hit graph. Right, it looks pretty similar. It looks kind of like a heart here. There is one thing I want to point out, and so sometimes students have the question of, well, how do we know to graph from 0 to 2 pi? And there are little tricks you can do to remember, how far to graph each one of these new shapes that you've never seen before. But it's easier just to really keep graphing until you start looping over that same shape again. And actually, if I go into my windows here, and let's just say I up this theta max instead of 0 to 2 pi, let's say we do 0 to 4 pi. And it'll be kind of hard to tell, but if you look really closely, you'll see that the calculator actually traces out this shape 2 times. So if you start overlapping on your graph, you start tracing out the same shape again, you can stop. Let's see this happen on the calculator. So there is 1, and then you can see you can barely see a few pixels changing here and there, but it's still tracing. So trace it out 2 full times. And if we instead made this 6 pi, you would notice that you'd be adding a few pixels here and there for a third rotation.